This project, I served as co-PI to my compatriot Paul Klopper as the PI, reflects really two things. One is he's a heck of a lot better qualified than I am to run a lab-directed project. That's why he's the PI on our contraction scholar project that is ongoing that he described earlier today. And two is I'm transitioning into retirement. The only problem is I've been transitioning into retirement for 15 years. But I've noticed that my private office has switched to a cube, and the cube is gradually being moved closer and closer to the back door. Now, someone might be trying to tell me something, but I'm ignoring them. This project had its genesis in really an investigation that Dan Geer of Federal Highway Administration did before he retired, when he was active, going out and visiting the DOTs that he was working with and just flat asking them what they do with their filters, and finding out more cases than not, they said, well, you know, if we can dewater the site, sure, we put a filter in, or if it's in the dry, sure, we put a filter in, but if we have to put it underwater, 9 times out of 10, we just ignore it. One could be environmental considerations, but probably an even bigger issue is the contractor's feeling that it just can't be done within the effective cost. And actually, it's not only Dan's DOTs that seem to have that feeling and other practitioners, but in the outset of this project, Paul and I put out a pretty extensive survey to practitioners, not only the DOTs, but many, many other agencies around the country. And I would say that feeling of, if it's really tough to get a filter underwater, just forget about it, is something that is ubiquitous throughout the United States. And I think those of us operating at this level in hydraulic engineering recognize that that is a big potential problem. So that was the genesis of this project. NCHRP 2422 started about 3 years ago. Wanted to develop specific guidance for design, construction, and maintenance personnel on the function of filters. Notice that it's an installation project, but people are making this erroneous decision of, hey, you know, it's going to be under the rock anyway, no one can see it, let's just forget it. There's a definite need for education in both designers, the maintenance folks, and the construction folks to really realize the importance of the filter in the overall countermeasure system. But the project did focus on, okay, if you recognize the importance, how can we install it in flowing water? So we were to consider placement of geotextiles and granular filters under countermeasures in a variety of situations, but with emphasis on underwater installation. That's what we set out to do. Now, just a real quick review, which I think is preaching to the choir here, but you know, filters can be a geotextile, it can be a layer of granular material, it could be both a geotextile and a layer of granular material, or the granular layer itself or granular filter itself can be composed of successive layers till you get down to the filtration capacity at the soil interface that you need. Just a quick picture then that I'm sure we all here are, whoops, wrong one. That we all are familiar with. Well, at any rate, the granular filters on the upper left, geotextile filter, pretty typical situation on the upper right, and then kind of what you would call a composite filter in that center item C. There's a lot of options. We did an extensive literature search and synthesis study. A lot of what we looked at dated all the way back to 1989 when FHWA and the TRB sponsored a scanning review in Europe of countermeasures and countermeasure installation processes. And some other information that we gathered came strictly from literature search, and then from a follow-up trip after the scanning review that Larry Arneson from Federal Highway, presently retired or now retired, Paul and I had an opportunity to visit Germany again and look in detail at how they handled both filters and other countermeasure systems, particularly on their inland waterways. But if you look down the list, essentially, you know, get a granular filter down in some way. Probably going to have to use a TREMIE pipe, because I think we're all aware of the fact that you just drop it in the water column in the surface, and what shows up at the bottom is not what your gradation was intended to be. There are some situations, and we'll touch on them, where a granular filter in flowing water could be a potential, but really geotextiles seem to offer the opportunity. Mechanical rollers, spreader bar or frame with the geotextile already attached to the countermeasure, particularly if you're laying in something like an articulating concrete block unit. A SANDMAT type product that I'll show you a picture of in a minute that is a proprietary product, many varieties in Europe and in Germany in particular. And then geotextile containers, or the so-called GEOBAGs, that we're starting to get familiar with in this country, but again, were first uncovered as a strong potential in the scanning review back in the 1990, 1900 timeframe. The other possibility is to use a crane or barge, help you lift that geotextile over and place it on a slope. Typically that's done for revetment in the dry, but in some cases it has to be done in the wet as well. Just a couple of pictures. This is Germany from the inland waterways trip in 2001. That is a SANDMAT on a roller, a filter, you know, on a barge, major mechanical system, but they're so serious about their filters in Europe, they've developed this type of technology to get them in. They realize the filter is the key part of the riprap, which in some cases we in the U.S. Are still learning. Hopefully we're getting better at it. There's typical installation in the U.S. Where you need to lay down a section of ACB, and you can pre-attach the geotextile filter at the bottom. Pretty obvious, pretty common, and that is used frequently in the U.S. as well as Europe. This is from the Bonner Bridge on the Outer Banks. We're starting to, the DOTs, North Carolina DOT, the DOTs are starting to realize that you need to get innovative if you're going to put your filter underwater. This was an emergency solution to a problem with a nor'easter approaching, where there was some real concern about one pier failing on the Bonner Bridge. This is an AJAX module with the filter wrap around it before the module is placed put in place on the bottom. And actually we found in our research that Lotwick Reese, before he retired at Idaho DOT, had used exactly this same approach with the AJAX module on two bridges on the Snake River. In our report, we have extensive case studies on both the Bonner Bridge and the Snake River installation. The SANDMAT, proprietary product in Europe, made up of two layers, a sandwich, if you will, of non-woven geotextile. You know, the geotextile by itself is buoyant, right? That's part of the problem of getting it down underwater. But if you take two layers of geotextile and put sand in between, hook stitch them together so they become a unit, and that's what you saw on that roller being laid, then you've got a negatively buoyant filter and a really double filtration capacity. Not only the filtration capacity of the geotextile, that top and bottom layers that form the sandwich, but also the sand in between that gives you the weight. If that's designed as an appropriate granular filter for the substrate, then you've got a double or insurance filter action there for you. There's in scanning review visit at a contractor site, there is a SANDMAT on a roller in a situation where you could place it underwater. It was demonstrated for us just out in their laboratory. Then, of course, the other idea is rather than put a sheet filter down, why not use the geotextile, which could be an appropriate filter, fill it with an appropriate granular material, sew it across the top, in this case, if you're going to fill it on site, and then drop it on site all around the area that you need to filter, around a bridge pier, for example. Be sure they overlap, have divers inspect it, and you have a good filter layer down. There's a typical picture in Germany. This was on a major coastal project where you can see the geotextile containers have been prefabricated and with a push barge are just pushed into place using GPS and divers to ensure that you get that adequate filter layer down before you place the armor on top of it. In addition to the sensitivity analysis, we thought we might try some proof of concept activities in the lab out at Colorado State University as a part of the project. So we conducted some diver-assisted installation, both granular and geotextile filters at a prototype scale in a large outdoor flume at Colorado State University. On the geotextile filters, we experimented with the buoyant non-woven geotextile just unrolled in the direction of flow. The divers, when they attempted to do that, compared it to, imagine if you're trying to hang a sheet on a clothesline in a high wind, the difficulty you'd have getting it down. And that's the way they described the action and the difficulty of this buoyant geotextile. But once you make it negatively buoyant, a la like the SANDMAT, then you've got a much more handleable situation as far as the divers are concerned. And we'll show you some pictures here and a little video later of their attempts to do that. The composite filter or the GEOBAGs placed on the bed adjacent to the pier. You could either do it as they do in Europe or have done in Europe, fill them, put them on a barge, get them on site, push them out where they need to go, and then inspect that you've got a good, complete, continuous filter. But something that we ran into that we thought we'd try is, how about if you have an overhead clearance problem, how do you get those GEOBAGs, those filled GEOBAGs, underneath the bridge pier, back under the bridge? And so what we experimented with was an idea that we hadn't really seen applied at a small scale in Europe, but had been applied in some coastal situations. How about having a diver take the GEOBAG down, put it in position or in the place that you need to place it, bring a flexible TREMIE hose down that has the capacity to pump the filter material and fill them in place on site. That way, if you have a bridge deck over you, you don't have that bridge deck clearance problem. And again, we'll show you our divers attempt to do this in the lab out at CSU. The granular filter, again, you know, nothing wrong with a granular filter, but if you're trying to place it underwater, about the only practical thing that we could run into, you got to get either a fixed TREMIE pipe or a flexible TREMIE hose, and you've got to get it practically down on the bed. Once you step it up from the bed just a little bit, those fines starts to wash away, and your in-place filter design does not meet the specs that you have with your design capacity. So we think many more viable or feasible potentials to get a filter down with geotextiles. Just a couple of pictures of the laboratory testing out at CSU. There's a pier in the large outdoor flume at CSU. You can see the divers in the water getting ready to go in. That's not a tidal wave approaching them in the upper right. The flow's coming to us from the upper right down to the bottom. That's just the stilling basin or the stilling of the water as it enters the flume at CSU. And then to experiment with you can see it there, the Merifix. That is the buoyant filter, no weighting on it. And then we couldn't get a SANDMAT in the US. You know, the geotextile manufacturers are missing the boat. If they could come up with a SANDMAT type product that was available in the US, there could be a huge market for it. On this one, Paul had to jury rig and make a negatively buoyant SANDMAT type product that we could, wouldn't act as a filter as it was designed, but our purpose wasn't to test the filtering capacity. Our purpose was to test the installation of a filter. And so as long as we had this negatively buoyant filter, and here Paul put them together and just weighted them with rods across in a lateral direction, so then and put them in a roll so that the divers could handle them. Okay, here's a test of attempting to get the filter, having the divers get the filters down. Yeah, I should talk about this. The low velocity test is the picture on the right, so I went on too fast. Pretty good luck with less than a foot per second of flow velocity. Okay, discharge of what, Paul, about 50, 60 CFS, and you can see the Mirify, even the buoyant filter on the downstream side in place, looks pretty good. They've got it weighted down to hold it there. The SANDMAT type filter on the upstream side looks pretty good as well. Kick the flow up to about 300 CFS, get 3.5 feet per second, and the divers had some problems. That's that sheet in the wind problem. The unweighted or the buoyant filter, that's about as good as 2 divers could do to get it in place in flowing water on the downstream side. On the upstream side, there's some problems with the SANDMAT or the weighted filter type product, but it's still, they were able to get it in place pretty effectively. Okay, we had already experimented in a previous project with putting the geotextile bags in place, but we had not experimented in 24072 years ago with this idea of getting the bag on the bed and then having the divers fill it. So these are available in the US, just this GEOBAG with a nozzle on one side. You can see the divers in the right-hand picture working at getting it under. And then a picture underwater, you can see the flexible TREMIE hose getting ready to put it in the nozzle. And then over on the right-hand side, you can see that GEOBAG well placed. Of course, if you were providing a total filter, that would provide, you would place a complete filter all the way around the pier. This was just to demonstrate the viability of getting that filter in place, even under high flow conditions. Let's see. Yep, we've got a little video clip that we're going to show you. We're going to hold it till the end. Let me just cover the lessons learned and our conclusions from this study. Ask Paul to come up in just a minute because he was the brainstorm behind this idea of having the divers go in the water, and nice little video clip of showing what they were dealing with when they did it. Our conclusions from both the literature search and also the work in the lab. The practical limit for a buoyant geotextile by divers is roughly 2.5 feet per second. For a self-sinking SANDMAT type product, you can get that in. They were able to get it in very successfully at about 3.5 feet per second. So there's a range there that you're dealing with. The underwater filling, the standard 3 foot by 3 foot GEOBAG with the integral fill port was done very, very successfully, even at that higher flow velocity of 3.5 feet per second. In fact, the divers' really conclusion on that was, this worked so well, the bag almost filled itself. And I think in general, Paul, they were able to fill those, each bag in about 2 or 3 minutes. Yeah, not seconds. That'd be pretty quick. Yeah, supersonic filter. No, in 2 or 3 minutes, they could fill each bag. We did do some extensive testing we don't have time to talk about of putting a granular filter down with the TREMIE at different levels. In our report, there are plots of how close you can come to the design gradation with how far you're off the bed, but you pretty much have to be right down in the bed to get a granular filter in place successfully. Conclusions then for 2442. A survey of practitioners across the U.S. found that in some underwater installation practices, that are used in other, that there are some underwater installation practices that are used in other countries. They're still not available in the U.S., even though they've been introduced and were introduced after the scanning review and introduced in the 24072 report. We're starting to, as you can see, with the Bonner Bridge problem, Bonner Bridge installation and the Snake River installation in Idaho, we're starting to catch on to some of these good ideas from Europe, but they're still not widely applied. We think that the use of a self-sinking geotextile composite, i.e. a SANDMAT, is an excellent product. As I've said, they're not available in the U.S. Some geotextile manufacturers are missing the boat. There could be a huge market for this if they could just be brought online. Another example is that GEOBAG placed on the bottom and filled in place underwater by the divers. That offers some real potential. When we did our survey, and Dan found out, practitioners in the U.S. indicated that they didn't even inspect the filter when it was placed underwater. But that's not the worst of it. As I said, in many cases, they're not even installing a filter. If they run into any obstacles or the design engineer for some reason thinks, well, it's window dressing, we're going to cover it with rock anyway and no one can see it, so why bother with a filter? Or in particular, if a contractor balks at the cost of getting that filter in, or in some cases, if we have environmental issues with getting the filter down. But our conclusion in looking at this, with the variety of things that are available, thinking of importing some ideas from overseas, from Europe in particular, our basic conclusion is that the current state of practice, US and overseas, provides a variety of filter material types and placement techniques to accommodate almost any underwater filter installation requirement that you might run into. We just need to educate ourselves a little bit better. And our bottom line conclusion, there should be very few instances where a filter cannot be placed as an integral part of a properly designed and installed countermeasure or scour countermeasure or erosion control countermeasure. The products from this project about to become available, NCHRP Report 887 is on our desk when we get back, and the final printer's copy to be reviewed one last time should be available in September 2018. It's an abbreviated version of the final report meant to be a practitioner's guide without, an extensive literature search and some of the things that go into a research report. The research report itself will be published or will be available online as a web-only document in full color, downloadable as a PDF, as volume 1 of web-only document number 254. And then the other product we produce, recognizing that there's a huge training need here for our designers, our contractors, and our maintenance personnel, we put together a National Highway Institute instructor guide in their current format, supported by about 100 PowerPoint slides in a set of 1-hour modules backed up by a 2 or 3 hour workshop that will be available online as a training document that you could download and use as a basis, say, for training your DOT folks or training the contractors that work for your DOT. That should be a very valuable document because there is a training need here. Paul, you want to show us a quick shot of your divers underwater?
Yeah, we've got just a 4-minute video of some of the challenges that we presented to our dive team. There's certified construction divers in the water at CSU in the large outdoor flume. And, we wanted to know what can you do underwater, and not just underwater, but in flowing water. And we also wanted to know what can't you do? When you get to a certain flow velocity, can you still do these things, install these different materials? So we have a, this doesn't come with narration, so I'll just kind of talk and explain what the divers are doing. This was a little over a year ago in 2017. We've got this prototype bridge pier. It's 18 inches wide and 4 feet long in the direction of flow. And we initially gave the divers a very modest, mild flow condition. It was less than 1 foot per second approach velocity on the pier. And we asked them to install some granular material with a flexible TREMIE hose. And all we were doing, it was just a contractor's, you all call it a trash pump, right? But we call it a solids handling pump. But I just rented it from United Rentals in Fort Collins. We pumped a slurry of water and pea gravel when the divers called for it. Now, the divers have comm lines that run through their tethers. So you see they are tethered. Now, in this particular instance, we bumped the flow up to 3.5 feet per second approach velocity and asked them to install the same materials.
You can see from the tension on those tether lines, they are operating at just about their limit. And of course, anytime you have divers in the water, safety is the primary concern. And they felt they would not feel comfortable in anything more about that sort of thing.
Okay, thank you
Yeah.
to Pete and Paul.
Thanks, Laura.